Road to Olympiad.
Welcome to RTO. Consider the following problem. Find all possible pairs of 4-digit perfect squares x, y such that exactly 2 digits in x are 1 greater than the corresponding digits in y, whereas the remaining digits remain the same. There are only 69 4-digit perfect squares. We can always check one by one if 2 of them are differ by exactly 1 for exactly 2 of the digits. But as always, it is quite tedious to compute all the perfect square if we do not memorize them. So we are going to analyze the property of the numbers to figure out the pairs rather than finding all the perfect square one by one. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by letting x and y be equal to a square and b square respectively, where a and b are integers. Notice that a square must be greater than b square. As mentioned in the problems, the two corresponding digits in a square is 1 greater than that in b square. Also, under these conditions, we must have a square minus b square, which is equal to a plus b times a minus b, must be equal to one of the following: 11, 101, 110, 1001, 1010, or 1100. Notice also that since a square and b square are 4-digit perfect square, both a and b must be between 32 and 99 inclusive, with a must be greater than b. This implies that a plus b must be between 65 and 197 inclusive. This will help us to simplify our calculation by a lot later on. With this, we can now consider those possible values of a square minus b square one by one. If a square minus b square, or a plus b times a minus b is equal to 11, we have no solutions here because in this case, a plus b must be equal to 11, which is not in the range we mentioned earlier. If a plus b times a minus b is equal to 101, we have a plus b is equal to 101 and a minus b is equal to 1. Solving the simultaneous equations, we have a is equal to 51 and b is equal to 50. So we have our first solutions. X is equal to 2601 and y is equal to 2500. If a plus b times a minus b is 110, we have a plus b is equal to 110 and a minus b is equal to 1. This gives us no integer solution for a and b, as we will be getting a is equal to 55.5 and b is equal to 54.5. If a plus b times a minus b is equal to 1001, we have 3 possible solutions for a plus b within the range. First, we have a plus b is equal to 143 and a minus b is equal to 7. This gives us a is equal to 75 and b is equal to 68. So we have the two perfect squares are 5625 and 4624 respectively. Second, we can have a plus b is equal to 91 and a minus b is equal to 11. Solving the simultaneous equations, use a is equal to 51 and b is equal to 40. So the perfect square that we are looking for here are 2601 and 1600. Third, we can also have a plus b is equal to 77 and a minus b is equal to 13. This gives us a and b are equal to 45 and 32 respectively, which correspond to the perfect square 2025 and 1024. If a plus b times a minus b is equal to 1010, we have a plus b is equal to 101 and a minus b is equal to 10. Again, we get no integer solution for a and b. Lastly, if a plus b times a minus b is equal to 1100, we have a plus b is equal to 110 and a minus b is equal to 10. The solutions we have here is a is equal to 60 and b is equal to 50. Thus, we have our last pair of perfect square to be 3600 and 2500. Therefore, we found 5 solutions for x and y, namely 2601 and 2500, 5625 and 4624, 2601 and 1600, 2025 and 1024, as well as 3600 and 2500. And this marks the end of our solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.